Hello everyone, today I'd like to talk about a device that is very common in a number of projects involving the Arduino and many other microcontrollers, and that is the potentiometer, or what they call a variable resistor. So this device is very important in a number of applications where you have variation of voltage or current or resistance. Let me have a closer look at it. So this is my potentiometer or variable resistor. As you can see, it has 3 pins. The first pin, this one with a symbol for ohms, or the resistance pin, that is used for inputting a reference voltage. For example, if you are going to connect it to the Arduino, you connect this pin to the power pin or the 5 volts. Then there is a middle pin, which is the input, and that is connected to the knob here, connected to this shaft, which keeps on rotating. And then the last pin is the ground pin. So in this case, it's going to be connected to the ground pin of Arduino board. So as you can see, the potentiometer has a knob which keeps on rotating. It rotates clockwise up to a certain level, then counterclockwise to a certain level. Let me now show you how this potentiometer works. So from here, you can be able to explain the simple working principle of this potentiometer. As you can see, the potentiometer has 3 terminals. In this case, I've used 1, 2, and 3. Where 1 is going to be the reference voltage you are using. For example, in this case, I'm using 5 volts, and then 3 is going to be connected to the ground, and then this middle terminal, which is labeled 2 here, is going to be connected to another shafting inside here, or what you call the wiper. So you find that the potentiometer contains a resistive track. So this resistive track will have a total resistance which is equal to the rated resistance of the potentiometer that you're using. For example, in this case, I'm using a 10 kilo ohm potentiometer. Therefore, the overall resistance of this resistive track is 10 kilo ohms. However, the purpose of this wiper is to vary that resistance because of, say, the potentiometer is a variable resistor. So what happens is that whenever you are rotating the shaft or the knob of the potentiometer, you change the position of this wiper. For example, if the wiper is now positioned at 25% from terminal 1 to terminal 2, so if you move it maybe 25%, it means now the resistance from 1 to, if measured, is going to be 25% of the overall resistance, which is going to be 2.5 kilo ohms. And then the remaining resistance will be 75%. So if you measure the resistance from 2 to 3, will be 7.5 kilo ohms. That is the simple way how this potentiometer works. So now you can have some simple examples to show you how these principles are applied. This is a small program that I'm going to be using to show you the simple parameters that are measured using this variable resistor or potentiometer. So in this case, I'll be able to show you the analog readings from the Arduino, and then I can be able to change those analog readings to voltage and resistance, and even show you the percentage of the reading from the potentiometer. So in that case, this is how my code is going to be. So I'll do a simple explanation here, although it's not really very hard code. So the first thing is to give a rated value for the potentiometer I'm using. For example, I'm using a 10 kilo ohm resistor, so I'll be rating it as 10,000 ohms. Then, since I'm interested in finding the resistance that will be measured by the step or the movement of the knob of the potentiometer, then I'll give that resistance a variable R. Then remember, we have to connect our potentiometer to an analog pin. For example, in this case, I'm going to be using analog pin 0. Then introduce other variables. The first one is for storing the incoming value from the analog pin. Then this percent is for holding the percentage value. Then in the setup, I'm just going to initialize the serial communication. There is no need of declaring the analog pins because they are automatically set as inputs. So in the loop, I will just get a reading from the analog pin using the analog read command. Then I will change that analog value to percentage using this map function here, where I'm going to be changing those integer values, because remember the Arduino has a 10-bit analog to digital converter, and then it can sample input values from 0 to 1023. So this map function will enable us to convert those input signals from 0 to 1023. Then I'll be converting them to a percentage that is from 0 to 100. Then I also have to convert the values to a voltage. Then those voltages can be converted to resistance using the ohms law. Then down here, I'll just put the printing file, the serial print functions, where I can be able to print the analog value, the voltage, the resistance, and then to be able to print the percentage of the value that I'm measuring. Let me upload this, and then we see how it's going to appear on our serial monitor. So after uploading, we open the serial monitor. So from our serial monitor, you can see now the knob is at the farmost end. therefore you're not measuring any value, the knob is not moved. So you see that the analog reading is 0, the voltage is reading is 0, and everything is 0. When we begin moving our knob, remember the analog reading will begin from 0 going to 1023, and our reference voltage is 5 volts. So it means that you are going to be moving from 0 going upwards, and the resistance, remember, is 10 kilo ohms. So as you keep on moving, the resistance will also keep on moving or increasing from 0 to 10,000 ohms or to 10 kilo ohms. And in each case, we shall be showing the percentage of movement of our knob or our shaft. So as you can see here, analog reading is 668, the voltage is 3.2, then the percentage is 66%. So as you go on, the values also go on increasing. And if you move the knob all the way to the right, then it means you have moved the analog reading to the maximum, which is 1023, and then the voltage will also be maximum, which is 5 volts, and the resistance will be the maximum resistance, which is 10 kilo ohms, and that is a percentage of 100%. This is one of the tests for checking if your potentiometer is working. So in most cases, if you try this and you find that the values are not changing, then that means there's a problem with your potentiometer, or maybe your connection is not correct. So before you apply your potentiometer in any project, it's always advisable to first try out this kind of experiment to test it. So from here I can show you a simple application of a potentiometer. So let me now show you a simple practical application of how to use the various parameters that we have shown in the previous example using our potentiometer. So because you can be able to vary the amount of voltage and resistance using the potentiometer, you can be able to control a number of items. So in this case, I'm going to be controlling the lighting of front LEDs with a simple movement of the knob of the potentiometer. So this is the simple program that I'm going to be using here. So as already mentioned, I'm going to put my potentiometer to analog pin A0. Then I'm going to have 4 LEDs that I'm going to label LED 1 to LED 4 that are connected to the digital pins 8, 9, 10 and 11. Then I've already talked about this other part. In here I'm just declaring the LEDs as outputs. Remember, I've already said that the analog pins don't need to be declared because they are known as inputs. Then I'll use the map function to convert the potentiometer reading to percentage. Then the percentage that is going to be read from here is the one that is going to be used to control the lighting of the LEDs. Remember, I have 4 LEDs. So the first case, if the percentage is less than 5%, it means all the LEDs are going to be off. If the percentage is greater than 5% and less than or equal to 25%, then you're going to light the first LED. Then the partner goes on like that. So in case the percentage is above 75%, then all the LEDs are going to be on. It's a simple application of how you can be able to apply the knowledge that you have received about the potentiometer. So let's upload this program and see how that works. So after uploading that program, and then you begin turning the knob of the potentiometer, you are going to observe that when you turn the knob, initially all the LEDs are off, but if you turn the knob, then the LEDs will begin lighting depending on the conditions that have been specified in our coding. So that's how the simple application of the potentiometer is done. So with this knowledge, you can be able to do a number of things. For example, you have already seen a number of knobs, for example, on the volume control of your radio or TVs, voltage and current control circuits. So this is the concept, and the basic idea is that. Hope you've learned something new today. Don't forget to subscribe to my channel and to like my other videos. Thanks for watching.